In the world of energy, what's holding us back is really dependence on fossil fuels to generate energy and an inability to efficiently store it. If we could just save energy and store it and use it when we wanted to, we would be miles ahead.
enerG2 is fundamentally an advanced materials company for energy storage. So we make ingredients that go into energy storage devices like batteries and ultracapacitors.
We founded enerG2 back in 2003, along with Aaron Fever and Chris Wheaton, and the focus was on commercializing some technology that Aaron had developed and really invented during his PhD work at the University of Washington.
We consider this one of the wonderful success stories of partnering with a venture capital company that really wants to translate some of the basic research findings that we have here at the university into something that's commercializable, something that is really useful for people. So the Center for Commercialization is an organization within the university that helps to introduce faculty work to private venture capitalists, which is exactly what happened here.
Through a series of state grants, we got the research funded at the University of Washington, licensed the technology out of the University of Washington, brought Aaron with us as our third co-founder, and established the company around this core technology that Aaron had conceived and invented within the walls of the University of Washington.
As I started looking into the energy field, I started to look into the different ways that people were storing hydrogen. It definitely kick-started my own interest in using a high surface area nanostructured carbon material to store energy. Initially, we looked at using the high surface area carbons to store hydrogen, moved on to using it for methane, and then eventually, probably in 2005 or so, discovered that we had produced a very good carbon material for storing energy in an ultracapacitor.
At the base level, we make a black powder to store electrostatic energy. It's fundamentally a black carbon that is formed into an electrode and put into an energy storage device. An electrode is the base level element of an energy storage device that actually stores the electrostatic charge. Without an electrode, you don't have an energy storage device. Without high performance carbon, you don't have an electrode for an ultracapacitor.
So today, a lot of electrode material coming into the market for energy storage devices is really based on existing precursors. So for example, activated carbons used in ultracapacitors today largely come from coconut shells. As we know, coconut shell did not evolve with the intent of being used in ultracapacitors. So it's not an optimal product.
What we're doing at enerG2 is really fundamentally different because we're taking a bottoms-up approach. We're actually building a polymer that has exactly the properties that we need, and we're designing the polymer using sol-gel processing. And so rather than having that coconut husk that we're stuck with, we've built the exact right precursor material to produce the ideal carbon. And that really gives us a huge fundamental advantage. We can engineer the pore structure, the pore volume, the density, the surface area, the different size pores. These are all introducing a tunability or an ability to engineer the structure of that material that really just was not there before.
I think the big transformation in energy storage is now going to be a result of tremendous advancements in material technology. So material science is really understanding the fundamental characteristics of materials and what they can do for a given application. The material science revolution that has really taken place in the last decade provides new tools that allow materials to be developed and understood and characterized on a molecular basis.
For energy storage, we believe it's the materials that matter. By starting with the precursor and actually assembling that precursor in a way that will reflect good performance in the final electrode material, we can not only have much greater control over the performance of the final product, but also we greatly simplify the downstream processing.
It's all very easy to accommodate typical manufacturing, which is what makes this really interesting because we're able to achieve a nanotechnology, but at a bulk scale and a bulk cost.
In August of 2009, we learned that the Department of Energy had selected enerG2 as a recipient of grant funds to build a factory in Albany, Oregon to produce ultracapacitor electrode materials on a very large scale. The plant itself, when it comes online, will employ at least 35 people in the Albany area directly as a result of the stimulus package funding. These are going to be permanent, important jobs in this area that we think will be the foundation for a lot of growth for enerG2, for the energy storage industry, and for the Albany area in general.
So the materials we make go into ultracapacitors and battery products that do end up right in products that consumers use every day. So for example, a hybrid electric vehicle captures electricity in a braking event and reuses that energy to boost the car in acceleration. It gets much better fuel economy through that kind of a process. Battery systems today are the limiting factor on how well those kinds of systems operate. We need a storage system that has similar energy density to gasoline. And our technology platform is one of the enablers to those battery systems.
So ultracapacitors have been around for a while, 10 to 15 years, but they're just now hitting that inflection point in their growth where they're achieving a great deal of adoption within some pretty important industries. Industrial cranes, uninterruptible power supplies in data centers, wind turbines, and they don't ever wear out. You don't ever have to replace an ultracapacitor. So you can build them into the application itself and know that it's going to last virtually forever.
I really think that we're right on the verge of seeing ultracapacitors adopted in a whole host of different applications. But later on, we'll be able to really tune that material and enable further electrochemical developments in other devices outside of ultracapacitors.
The high-level vision for enerG2 is to make gasoline obsolete. So if you think about the social impacts of oil today, the strategic implications of our dependence on oil, and the cost and the environmental impact, huge, huge value to making gasoline obsolete. We can do that with electrical energy storage, and that's what we're focused on here at enerG2.